All right, so today I'm going to continue with the segment addition lesson that I started on yesterday. I'm going to start off with an ACT question that uses that exact same concept. The first statement says that points B and D lie on segment AD. All right, so when you see that symbol right there, that line or that little bar that they put on top of the AD, that means segment. That lets you know it's a segment. So that sentence is letting you know that these 2 points lie on this segment. That's all that first statement is saying. That's the second thing that it's stating. It's letting you know that the segment AD is 38 units. So this whole thing from start to finish is 38 units. 38 units. Next thing stated is AC is 26 units. All right, so that means now that I have my 38 showing, I also have to indicate where my 26 is showing. So that goes from, and that brings me to about right here. So every time I read a piece of information, I go right back to the diagram and identify that same information on the diagram. All right, next thing I read, okay, segment BD is 20 units long. 20 units long for segment BD. So from here to here, that's 20 units long. So that means that's going to be another spot I have to identify. And there's my 20 units for segment BD. So the very last question is, and this is what we're trying to figure out, how long is segment BC? So all right, so what makes this problem tricky is that we have some overlap right here in the middle. See this 20 part, it overlaps the 26. So to get to this part that I'm pointing at, we can't go directly to it. What we have to do is figure out this missing piece first, and then we can work our way into it from that way, all right? So what we have to use is the 38 minus the 20. So that means this has to be 18. If part of this is 18, that means the other part is 20. So that gives me my 18 right here. And I didn't show the math. That was just subtraction. And so that's where we're going to start. We at least know that that segment AB is 18, even though none of the instructions indicated or asked for the length AB. So now I put my attention on the 38 and the 26. Once again, if I subtract, if part of this is 26, that means the other part over here has to be 12, because 38 minus 26 is 12. So that means this piece, CD, is 12. And notice this has been nothing but a series of subtractions. So now I know what BD is. BD is 20, and out of that 20, I have 12. So that means this has to be 8. And if it's done correctly, if you add all three of these numbers up, you should get 38, which should be the whole amount. Now, for that example, you notice I didn't write down a lot of subtraction, but if you listen to what I'm saying, it's really that thought process that I'm trying to get you in the habit of forming when you have to figure things out given limited information. Notice how when I notice something, if I'm given the information, that's my if. If I have this, then what does that mean? You get what I mean? If then. So that's like one of your fundamental logic processes when you're dealing in mathematics. If this happens, then this happens. Because math is very structured, and we know that certain things behave a certain way. So that allows you to make assumptions that are true. So that process is the same process that we use anytime we're figuring things out. If this, then what? If that, then what else? You know, that type of thing. So I'm going to try to find one more example, and then I'm going to go over that one, and that's going to be my lesson for today. All right, so here's a trickier type of problem when we talk about segment addition. We know what the full length is, but the full length happens to be an expression and not a number. So from A to C, that's equal to X plus 10. So we don't know what that measurement is yet. Now, what they did give us is the smaller piece from A to B. That has a length of 5. But now all of a sudden on the other side from B to C, we don't know what that one is either, and we use another expression. So this is that example that I was talking about on yesterday, where the statement will get you through the problem. The statement itself can help you figure this all out. So we're going to solve for x, which is the missing variable. And from that variable, we can find out the segment AC and the segment BC. So we have to start with a little bit of truth telling, right? So if we take a look at this whole diagram, what we do know, if we don't know anything else, we know that if we go from A to B plus we go from B to C, what that is equivalent to is going from A to C. And that's our statement. Our statement is what's going to help us through here. All right, so I just have to kind of sit on here for 1 second. Remember, what I said was a true statement. Segment AB plus segment BC is equal to segment AC. That's a true statement. And by definition, this is your solution. You get what I'm saying? So we've already won before we even started, because we already know the solution, because the solution is a true statement. All right, so AB, segment AB, that's equal to a 5. All right, so I put that in. That's directly from the diagram. BC, that's a 2x plus 6. So right here, I put a 2x plus 6. And I say equal to, and then AC happens to be x plus 10. So all I did was sit everything in the exact place they are supposed to go. And this sets up my equation. All right, so now I have 2x plus 11 is equal to x plus 10. All I did was combine like terms over here. I added the 5 and 6 to get that to an 11. All right, now I subtract 11s on both sides. Now I have 2x is equal to an x minus 1. Because remember, over here, 10 minus 11 is a negative 1. All right, now I subtract x on both sides. And 2x minus x is equal to x. And now I have x is equal to a negative 1. So x is equal to a negative 1 now. And this is where I start putting everything back together. Remember, x is equal to a negative 1. So I'm going to just do mine by replacing the x with a negative 1. And then basically what I'm looking at here is a 9. All right, so that's equal to 9. AC is equal to 9. So over here, I can say that's equal to 9. Now, if this is 5, then that means BC has to be 4. See that? BC has to be 4. And it will happen even if I were to calculate right here. If I were to put a negative 1 right there, I'll get a negative 2 plus 6 is equal to 4. See what I'm saying? So all of these numbers have to verify and check right back out so that everything remains equivalent to each other. So 5 plus 4 is equal to 9. So we just figured it out. And this is the trickier one, because remember, they didn't give you the full length. They gave you a piece of the length, and then we had to use 2 more expressions and still set up our statements. Different approach, but the idea is exactly the same. All right, you can find me on YouTube, BJ Jeffries. First picture, the one right here with this camel, pyramids in the background. Go there, subscribe. I'm putting up videos each day I show up to work.